In this video, we'll be looking at 10.2, segments and their measure. Our essential question will be, how do I use the segment addition postulate? So first we should define postulate. And postulates are rules accepted without proof. Postulates are rules accepted without proof. So the rule of postulate is the points on a line can be matched one-to-one with real numbers. And what that means is kind of just explaining what a ruler is. So if I have, say I drew a ruler, and we're just going to start measuring our ruler, not quite at the end, but right there. And we're going to split it into fourths. So there's 1, there's 2. I could assign the numbers with letters. So I could say this is point A and this is point B. And then I can go from point A to point B. I could say A is 0 and B is 2. So the length of the segment is the distance between 2 points. And we can find that by saying that the measure of AB is equal to the absolute value of A minus B, or the absolute value of B minus A. It doesn't matter the order that we subtract them in, because we're going to take the absolute value, and distance will always be some positive number. So for this example, I could say the measure of AB is equal to the absolute value of 0 minus 2, which is equal to the absolute value of negative 2, which equals 2. So we can see that the distance from 0 to 2 is 2. So one thing I want to point out is what this means, so we make sure we know. This is meaning that is measure of AB. Let me put my line segment notation on it. Measure of segment AB. So that's what that means. That little m is telling me the measure, to treat it as the measure of. So part B, the segment addition postulates. This is the big part of today. So the segment addition postulate states, if A, B, and C are collinear, then B is between A and C if and only if AB plus BC is equal to AC. So what this is getting at is that if we have a line segment AC, then it makes sense. It doesn't matter where I place B in here. It makes sense that if I add AB to BC, then that would equal AC. So AB plus BC is equal to AC. That just makes sense. When you look at the picture, it can really just kind of just makes sense. Okay, so let's look at an example and see if we can use this. If MO equals 32, find the value of each of the following. So if M to O is equal to 32, the entire thing equals 32. So we know that, let's put N right there. We know that MN plus NO is equal to MO. The piece plus the piece will equal the whole. So I can say MN plus NO will equal MO. We can just gather that without even talking about solving for the variable or anything, just by looking at our line, we can see that that is kind of like inherently true. So now let's plug in our ideas. Well, Mn is 3x, so I have 3x, plus NO is x plus 16, so I have x plus 16, and that's going to equal what we were already told, that MO is equal to 32. So we can say it's equal to 32. And now we're just going to solve for x. So I have 4x plus 16 equals 32. Subtract 16. We have 4x equals 16. Divide by 4, and we get x is equal to 4. So we found x equals 4. Now Mn, we see is 3x. So I have 3 times 4 equals 12. So I just plug my x in to what Mn equals. So Mn is equal to 3 times 4 equals 12. NO is equal to x plus 16. So we'll use 4 plus 16. NO is equal to 4 plus 16, which is equal to 20. So I'd like you to go. I'd like you to try number 2 on your own. The key to number 2 is to try to draw the picture before you begin. If you draw the picture, draw it like we have M to O, and place all the information in the picture. It'll make it much easier to see how to set this up. So pause right here, see if you can try this on your own. Okay, so hopefully you tried this on your own. Let's see. So suppose J is between H and K. We don't really care. We're just drawing a picture for ourselves. It doesn't have to be accurate or beautiful. We just want to make sure it represents the idea that's being presented. Suppose J is between, so we're going to have something between. There's J, and it's going to be between H and K. So this picture represents what the idea is talking about. So now let's start labeling things. Well, HJ is 2x plus 4. And then JK, J to K, is 3x plus 3. And then the entire thing from one end to the other is 22. Like that. And you don't have to, remember, this is for your own, to help you view this. So this is your picture. It does not have to be perfect, doesn't have to be accurate, and you're not graded on the picture. It's just a visual representation of what the problem is asking, so that we can have like an idea of how to better approach it. So now that we see how this is set up, well, we know if we add AJ, HJ plus JK, that would equal HK. So let's write that little equation. HJ plus JK is equal to HK. We add the pieces together. Piece AJ plus piece JK will equal the whole HK. So now I'm going to replace everything. So I have 2x plus 4 plus 3x plus 3 equals 22. Combine like terms, solve for x, all that jazz. So we'll get 5x plus 7 is equal to 22 minus 7 minus 7. 5x equals 15. Dividing by 5, we get x is equal to 3. Now we can find the length of each segment. We know x is 3, so I just plug it in. So it's going to be equal to 2 times 3 plus 4, which is equal to 6 plus 4 is 10. Plugging in for JK, we have 3 times 3 plus 3 is equal to 9 plus 3, which is 12. And then we know 10 plus 12 equals 22, so we can feel good about our results. So that's all that we have for section 10.2. Thank you for watching this video, and I hope you have a great rest of your evening.